All right, in our last video, we were talking about balancing chemical equations and the rules to doing this, okay? We talked about subscripts, coefficients, and parentheses and how that affects the number of atoms in each reactant or product. We also discussed what reactants and products were. And then we went through 4 steps for balancing an equation, which all I did was state what they were. I didn't actually show you what they are, so we're going to do that here. Okay, on this worksheet, I'm going to go through 4 examples that are different from one another and show you how to do it, and hopefully that spurs you on to be able to do the rest of them, okay? So here we have N2 plus H2 yields NH3, and these little blanks here in the front are where you're going to write numbers in. Those are called your coefficients, and we'll talk about how and why we do that here in just a second. But basically it's this: N2 plus H2 yields NH3. And that's true. That is what happens. Nitrogen and hydrogen, both diatomic molecules, when added together, will create NH3, which is ammonia. But what we ran into last time was saying that, okay, if I represent nitrogen like this, diatomic molecule, 2 hydrogens, diatomic molecule, then this yields, or it gives me, remember that's what this arrow means, gives me 1 ammonia molecule, which is fine, and although it's true, it's not mathematically correct, right? Because here I have 2 nitrogens, here I have 2 hydrogens, but on this side, I have 1 nitrogen and 3 hydrogens. And that's not equal. I should have 2 nitrogens on one side and 2 on the other, or 2 hydrogens on one side and 2 on the other. And so what we do is this: we can't just break them apart and say, well, never mind, there's 1 nitrogen here, so I'm just going to have 1 here, because nitrogen doesn't float around by itself, right? It's always a diatomic molecule. So we have to use coefficients in order to do that and to make sense of it. So keep in mind one thing here. This front part here is referred to as the reactants. Okay, these are the things that are reacting, chemically reacting to form something new. This arrow means basically the equal sign, or it's going to yield, or it's going to give us something new. And this part over here is our product. Okay, this is the new thing. So nitrogen, hydrogen together, something reacts, and we get a new thing, which is our product, NH3 ammonia. So we want to make these equal from the left to the right. And so in our steps, number 1 says to check the valence numbers and make sure the diatomic molecules are diatomic and all that. You don't need to do that here because I already did that. They're all going to be correct equations, okay? So skip to step 2 for all of these, which says count the atoms of the reactants and products. Well, we just did that. 2 nitrogens and 2 hydrogens for reactants, but the products are 1 nitrogen and 3 hydrogens. So they're not equal. Step 3 says pick an element that's not equal and add a coefficient. I could start with any of them, but I'll go ahead and start with nitrogen, okay? There's 2 on the left, 1 on the right. I already said why I can't break this apart. But what I can do is this: I can make this 2 NH3s, okay? So in other words, I can do this. Put a coefficient here. And what that tells me is basically now I've made 2 different molecules here, 2 ammonia molecules, right? Here's 1, and here's 2. And in doing so, I've actually changed the number of hydrogens and nitrogens. Now I have 1, 2 nitrogens, and 1, 2, 3, 4, 5, 6 hydrogens. Now I just satisfied this. Okay, nitrogens. I have 2 nitrogens on the left and 2 nitrogens on the right. So that's good. However, now I've created another problem, which is I have 2 hydrogens on the left with my reactant side and 6 on my product side. That's not equal, right? So what can I do here to make these equal? Well, I can't break this down any further because I just said how I need this for the nitrogens. But what I can do is play with my hydrogens on the left side and the reactant side. And so if I do this, I can go to my hydrogens and say, all right, I've got 2 of them, but I want 6. Let's take 3 hydrogen molecules. And so now up here, technically what I'm doing is, sorry, you can't see that. Technically what I'm doing is throwing in 2 more hydrogen molecules. So I have 3 hydrogen molecules, as I've represented here. And of course 3 times 2, because there's 2 in each molecule, gives me 6. So now I'm left with 6 hydrogen molecules. Okay? 2 nitrogen on the left in my reactants, 6 hydrogens. This is my yield sign, which again should mean more like an equal sign when we're looking at it mathematically. And that gives me 2 nitrogens on the right and 6 hydrogens. So now it's all equal. Okay, and the point of doing this is, I can just put a 1 here because my nitrogens stay the same. The point of doing this is now I understand completely what's happening. I have 1 nitrogen molecule and 3 hydrogen molecules that react chemically, and they give me 2 NH3 molecules, or 2 ammonia molecules. Okay? And that's what it says here, but mathematically now I have it correctly represented. Let's do number 2. Technically it's like this, but that 3 at the end is referring to the O, and Cl is chlorine. So we have 3 different elements here, okay? And so if I'm going to look at this that way, I'm going to say, let me do this. Sometimes this takes a lot of space. You might need a blank sheet of paper, or you could even use like the back of this paper if you have space, or the margins work as well. So I'm going to say, all right, potassiums, I have 1, chlorine 1, oxygen, I have 3 of those. Okay, and here I can see that this molecule is going to break down. It's going to be broken down, and it's going to have two different molecules now after this. One is potassium chloride, KCl, and one is oxygen, diatomic molecule. So here I have 1 potassium, 1 chlorine, and 2 oxygen. So my steps for balancing an equation, remember you're going to start at step 2, count all the atoms, which we just did. Number 3, pick an element that is not equal and add a coefficient. Okay, so one that's not equal, add a coefficient. Let's see, I have 3 oxygens, 2 oxygens. There's no way though I can just multiply and get them to be the same by multiplying on one side. So I can do this though. I can do 3 oxygens. These are O2s, so that will give me 6 oxygens. And if I put a 2 over here, that will give me 2 times 3 is 6. So now this is a 6. 6 oxygens, and 6 oxygens, so those are good. Now, in doing that, I changed some stuff, right? I'm fine on the product side, it just changed the oxygens, but on the left, it also changed chlorine and potassium. So I've got 2 potassiums, 2 chlorines. Because this is a coefficient, it's multiplied by all of those, okay? So 2 potassiums, that's pretty easy. Now I'm just going to say, let's do this. Let's put a 2 here, okay? This will give me 2 potassiums, and actually at the same time gives me 2 chlorines. And now I can see 2 potassiums, those are equal. They're balanced. 2 chlorines, balanced. Everything's balanced, okay? With these 2, 2, and 3. Okay, let's try another one. Try number 7. CH4, O2, got 1 C, 4 H's, 2 oxygens. It's going to yield 1 C. Got 2 oxygens here, 2 hydrogens here, and 1 more oxygen. So it's actually 3 oxygens, okay? How can I change this around? Well, step 2 says count all of them, which we did. Step 3 says pick an element that is not equal and add some coefficients. So my carbons are good. However, my hydrogens, 2 and 4, are not. And so how about I go ahead and do this. I'll put a 2 here. Okay? So this is going to give me 4 hydrogens and 2 oxygens. And I've already got 2 over here, so that's 2 and 2 is 4. 4 oxygens. Okay, in doing that, carbons are balanced. 4 hydrogens, those are balanced. And now I have 4 oxygens because I changed that. But I only have 2 here. Well, that's kind of an easy fix. All I need to do is put 2 in front of my oxygens up there, and I get 4, because 2 times 2 is 4. So now I have 4 oxygens and 4 oxygens. It's all balanced. So that's a 1 and a 1, because 1 times anything is still itself, okay? That's number 7. We'll leave it at that. Best of luck in getting all those done up to number 21, and be sure to look at the answers up on the board just to see if you're doing this right.